Hi guys, I'm out here at the elementary school today, and it is to bring you the lesson of the scale distance between the planets. Usually I have all of you with me and you get to help carry all the equipment for this, but today I am on my own along with my camera person, my daughter Michaela. But we are, so we're going to look at that scale distance between planets. So the other day we did the sizes of the planets and the scale sizes. We saw that Mercury was very small, Jupiter was fairly big, and the sun was so big I couldn't even fit it into my living room. So I came out to the school today so that you'd be familiar with the area that I'm using, and we could look at this using scaled down measurements. Okay, we're using that math. When we talk about scale models, we're talking about using math and relating it to the size of the real thing. So as you can see, we are at about right between the little kids playground and the big kids playground. And to do this measuring today, I'm going to be using a GPS unit. Okay, this unit is something that I use for my hobby called geocaching, and I'll have to go into that another time. This uses the satellites in the sky that are orbiting the Earth. So those would be, so actually anything in the sky that orbits another thing is considered a satellite of that. So we've got a natural satellite, which is the moon, but then those satellites that are being used by the GPS unit are man-made satellites, and they communicate, and it tells about the position where we are on Earth. So I'm going to get started today. I put in the starting point, which is about right here. Okay, and I'm going to put our sun in this area. Okay, we'll just stick that into the ground and add the sun on. So I've got all my, let's see, there we go. And now we have the sun. And by the time we get to the end, that may slip down, but we'll see. I think we've got it. So that's our sun. It's a little bit wrinkly, but that's okay. So from there, using the math, okay, about 15 feet away from the sun, we're gonna put Mercury there. So that's not very far. Let's see. About right here, we're gonna put Mercury. Okay, so Michaela Morrow is gonna hand me the thing for Mercury. Actually, I might be able to, oh, that works. Okay, and we can see that Mercury is fairly close to the sun. So each of these little posters has a little bit about the planet on it. This one says Mercury is the closest planet to the sun, so it's very hot. Mercury has almost no water and is a very small rocky planet. This planet does not have a moon. Another thing to remember is that Mercury can also get very cold. When it's turned towards the sun, yes, it's really, really hot. But when it turns away from the sun, it can get very cold because it has a very thin atmosphere. Okay, so moving on. I'm going to move towards Venus. Okay, and again, this paper I'm looking at is helping me out with the distance from the sun, all that math. So here is about where Venus would be. Okay, and so from Venus, we can still see that sun fairly well. Okay, here we have Venus is the second closest planet to the sun. Its atmosphere is mostly made of carbon dioxide. This planet's atmosphere does let heat escape easily, which makes actually does not let heat escape easily, which makes it the hottest planet, even though it's second from the sun. Okay, continuing on, Earth, not too much further, a couple steps away, using these scaled down measurements right here actually. Okay, this is one of the reasons why we can see Venus in the night sky so easily. If you look up, you might see a really bright star. Most likely it's Venus and not a star. Okay, so here's Earth. Earth is the only planet that we know of that supports life. This planet's atmosphere keeps temperatures from getting too hot or too cold. It is the third planet from the sun. Of course, we know that a planet that is this distance from the sun is in something that the scientists call the Goldilocks zone, perfect for life. So not too hot, not too cold, just right. Okay, moving on to Mars. Let's see. With these measurements, about 57 feet from the Earth with these scaled down measurements. So we're going to put Mars in right here. Okay, and the poster for Mars. Okay, Mars, of all the planets, Mars is most similar to Earth. Mars has 2 small moons. It has a thin atmosphere and is much colder than Earth. Okay, so again called the red planet. And if we look at these planets from the sun, we can see all of them. We can see the sun fairly easily from here. These are the inner planets, and I'm going to stop the video, put it into 2 places. The second one's going to be longer because we're going to do a lot more walking when we see the outer planets. The next part between Mars and Jupiter, there would be an asteroid. The asteroid belt would be in there, and that's where those asteroids are revolving around the sun. And of course, those are rock and iron objects. So I'm going to go ahead and have, I'm going to go grab some more of the stakes for the ground, and we're going to continue on with the outer planets.